so we're going to look at geometric sequences today. To do that, I'm going to start with we're going to look at geometric series, and I'm going to start with geometric sequences. What is a geometric sequence? It's a grouping of numbers that are all related to each other, like this one right here. Do you guys know how these numbers are related to each other? What am I doing each time to go to the next number? Yeah, it's multiplying by 2. Okay. What about these numbers right here? This might be a little harder. Ooh, you're dividing by 5. You go 625 divided by 5 is that, divided by 5 is that, divided by 5, right? Now, instead of saying divided by 5, can you say it with multiplication?
Yeah, it's multiplied by either a factor or like...
By 1/5. Thank you. Sorry, she's faster than you. Okay. If I multiply 625 by 1/5, I would get to 125, right? That's the same as dividing by 5. Oh, you guys are good. So those are geometric sequences. Geometric series is when you take them and add them together. So this is a series. Notice it's the same as this, except we put plus signs. And we can keep going here, but actually these numbers keep getting bigger. You'll be here all day if you do that. And so these are known as finite geometric series, okay? Finite. So that means you don't go on forever, but you stop. You have a certain number of numbers that you add together. So how many numbers am I adding together right here? 5. That's why it says S sub 5. Now, I don't really like my S's because my S's kind of look like 5s, or my 5s look like S's, whatever. But we have to do it because S stands for sum. Okay, so for the next one, it'd be S sub 4. And if I write it all out, this is what it would look like. That's a geometric series. Now, if you were to add these together, it might be a little arduous. These ones actually aren't that bad. They're pretty simple. But I want to use the simple ones to do more complicated ones later with you guys. And so it's kind of neat. We got this formula for a geometric series. Have you guys seen this formula before? Yes. Okay. Now this formula is crazy to me. I cannot believe this formula works. Whenever I see it, I mean, I've taught this for I don't know how many years, but every time I see it and I use it, I'm like, how does this freaking work? This is crazy. And so what I really want to do too, if I have time, I want to show you guys how we actually get that formula. If we don't have time to show you that today because today's a shortened day, I'll show you guys on Tuesday because I'm not going to let this moment pass up. This is like rad stuff. Okay, and I don't know if you know this, you probably don't, but this is like a number theory concept, and number theory is my favorite branch of mathematics. So anyways, let's talk about what each of these letters mean. The A is the first term. The first term in the series, okay? And then the R is the common ratio. Okay, so like really quick, this one right here, what's my first term for this series?
1.
It's 1, that's pretty obvious, right? Now, what's my common ratio? What do I have to do to get to each next number? Yeah, it's multiplied by 2, so the common ratio is 2. Now, normally when you see ratio, you think fraction. But isn't 2 also a fraction? You can say 2 over 1, right? Now, more commonly, you'll see fractions more than just a whole number. But I chose 2 because that one's really easy. And we always want to do the easy ones first, right? As you're trying to understand the new, big, ugly formula, dude. Okay, last one is the N, and that's the number of terms. So let's practice this. Let's add this first one together. But instead of actually adding them, let's use the formula. Okay, so what's our A? We already know this. We did it. It's 1, yeah. And what's the next one? What's our R?
2.
It's 2. And then how many terms are we adding together?
4. 5.
There's 5. Okay, now, I said 2 or 1, which we all know is 2. Okay, and then how do we actually get to? What if it wasn't that easy? Well, what you do is you pick one term and then you divide it by the term right before it. So you take 8 and then divide it by 4, and then, hey, that's 2 over 1, which is 2, right? Let's try it again. You kind of always want to try it twice. And so if I try it again, let's pick 16. And then the number right before 16 is 8. So I divide by 8. And look, we get the same thing. Oh my gosh, that makes it the common ratio. And then N, which we already said was 5. Okay, so now let's plug it all into our nasty looking formula. I can't believe this works, guys. This is crazy. No, but I'm serious. This is nuts that this works. Like, I know, but it works. Like, look how ugly this is. This is supposed to add all these numbers together? I don't believe it. Well, I do because, yeah, whatever. Okay, so I plug them all in. Okay, at the top, I've got my A in there. I got the R right there, and it's raised to the power of 5. That's what the A, the R, and the N. Okay, then on the bottom, I have my 1 minus the R. All right, let's see what we get. We do have some negatives going on here. On the top, I get 2 raised to the 5th power is 32. And then I have times 1. This times 1 does nothing, so go ahead and ignore him. Doesn't it suck to be ignored, huh? Right? Poor 1. Everybody said, "Aw." Oh, wow, you guys don't have any hearts out here. And then we have 1 minus 2, which is a negative 1. And so I get negative 31 divided by negative 1, which equals? 31. That's our answer. What? Is that really true? Here, let's check it out. What is 2 plus 1, Stews? 3. Okay, so we got 3. What is 3 plus 4? 7. See, that's not that hard, huh? And what's 7 plus 8? 15. And what's 15 plus 16? What? That worked. Isn't that nuts? That's crazy. We did all this dumb stuff right here, and it actually took into consideration all these terms. That is crazy. That's why I really want to show you. I mean, I don't think you care, but I want to show you how we actually get this, because I think that's crazy. Let's do it again. Okay, so S sub 4. Let's do this guy right here. Okay, what was the A? What's the A for that one? 625. And what's the? Let's do the R now. Or no, the N. The N's easy. How many numbers are there? There's 4 numbers. You can kind of cheat and just look right there, or you can count the 4 numbers. Okay, and now let's find our R. Now, remember I said you pick a number and then you divide it by the previous term, the previous number. So if you picked 125, what would you divide it by? 625. But those are big numbers. I'm not going to do that one. Let's go. Ooh, 5 and 25. That's a good idea because that's way smaller numbers, right? And what do you get when you simplify that? 1 over 5. 1 over 5. And you guys already found that, remember? You guys are like, oh, it's divided by 5. And that's the same as multiplying by 1/5. Okay, so let's try another one because we want to check it to make sure. What would you divide 25 by? 125. And so I would simplify this by dividing the top and the bottom by what? By 25. Okay, and then what's 25 divided by 25? Uno. And then 125 divided by 5 is 5. So it works. Okay, so this is our common ratio. Now let's plug it into all the nastiness. All right, so I have 625. That's my first term. And then, oh, man, look how ugly this looks. I have to take this fraction and raise it to the 4th power. On the bottom, I have 1 minus 1 over 5. Now, even though this looks really ugly, guys, it actually comes out really clean. So watch it. Watch how it works. Okay, so we have 1 over 5 raised to the 4th. Now, that would be 1 over 5 times 1 over 5 times 1 over 5 times 1 over 5, right? 4 times? Hopefully I said it 4 times. But so all you really have to do is do 5 raised to the 4th power, okay? But we'll get there in a second. Down here, I'm going 1 minus 1 over 5. Now, 1 is the same as 5 over 5. Do you guys know why I'm writing 1 as 5 over 5? Yeah, it's the common denominators, right? Okay, so I have 5 over 5 minus 1 over 5. That'll give me 4 over 5. And then on the top, what's the 5 raised to the 4th power?
625.
Yeah, it's 625. That one actually, that's a quinkadink. That doesn't always happen, but anyways, we have 625. And so now let's go. How do I change? What am I going to change that 1 into so I can subtract this nasty fraction from it? Yeah, so we're going to go 625 over 625, and when I subtract those, I get 624 over 625. Yeah, it looks ugly, right, huh? And on the bottom is still 4 over 5 is chilling right there, but now something really cool is about to happen. 625 times this fraction, what happens?
You can't pull it out.
They die! Look, they died! Yeah, but Jesus came back to life. You know, yeah. Okay, the 625s, they're not coming back to life. They're gone. Okay, and then what do I do after that? Let's see, we got 624 over 4 over 5. Whoa, you guys know how to do that?
Isn't it negative 624?
Not, dog. It's not because this number is bigger than that number, so it should be positive. Okay. All right, so whenever you divide a fraction, you can multiply it by the reciprocal. Good. Okay, so I'll go 624 times 5 over 4, right? That's the reciprocal. It says 4 over 5. The reciprocal is 5 over 4. And then I'm going to do some business here. Where'd my pen go? I cross multiply or cross cancel. So we're going to make this into a fraction. I'm going to divide that by 4, get 1. Divide this by 4. I get 6 divided by 4 is 1. And then it's 22 divided by 4, which is 5. And then I get 24 divided by 4, which is 6. So now I get 156 times 5. Oh, man, I kind of have to write that out. I don't want to do that in my head. All right, so times 5. I go 6 times 5 is 30. That would be 28. And that would be 7. 780. So if you actually add all these together, what you gonna get? Yeah. Now I don't know if which one you think is easier. Probably doing this by hand is easier, like because that's 150, and you add 5, so it's 155. If you add 155 to that, do we get 780? Holy crap, we do! It works.